Hey guys, in this video I'm going to be talking about the graphs related with motion and practically what the graphs show and how we can distinguish each graph from each graph. So we'll start off with the first graph, and let's say in a graph you want to show, let's just label the axis first, just a sec. Let's say this is time, and never forget to put the arrows over here because the teachers, some strict teachers might cut you down on that for not having a perfect graph. So never forget to draw arrows like this because it shows that they, oh god damn. Anyways, these arrows show that both of these axes go on for an infinite amount of time, and this is velocity. This axis is velocity. So if you're asked to show a graph of an average speed, so speed that remains the same over time, what do you have to do? Well, that's probably the simplest of graphs. You just draw a straight line on what the speed is. So let's say this point over here is 55 kilometers per hour, like we did in the last video. Chem h sorry, chem h -1, and it's keeping the same speed over time. It's not changing. So that's pretty obvious that's quite obvious what this graph shows, right? It just shows the constant speed over time. Now, another factor that you really need to know for graphs is the area below the graph. So what this area shows, and you would really need to know that because that is quite important in grade 9. Well, and if you're confused what the area shows, just do basic maths, right? How do you find the area of a rectangle? Well, it's quite easy. It's base times the two sides, so height times base. So what is the velocity? What's velocity? What's velocity multiplied by time? What is velocity multiplied by time? Well, that's distance, right? So velocity, which is 55 kilometers per hour, multiplied by time, and how much time it takes, that's the distance. Because if they did that for 1 hour, so if this was 1 hour and this was 55 kmh, well then 55 times 1 will be 55 kilometers, so that's the distance traveled. So practically this graph, the area below the graph shows the distance traveled, right? This is the distance traveled, and you also need to know that because that's quite important. And they in a test or in a worksheet they might ask you to find, all right, so how much distance, derive the information of how much distance they traveled from this graph. So that's how you do it. Next graph is what if you have the same axis, right? The same axis, velocity and time. Ah, damn. What is happening? Right. Velocity and time. So I'm not going to label the axis because I'm telling you guys it's velocity and time. And you want to show acceleration. So let's say a car's initial speed is somewhere like 20 kilometers per hour, and it's going at a steady acceleration of 10 kilometers per hour. So that, and this is velocity, this axis is velocity, uh, and this is time. So well, it's increasing its speed over time. So it would be a diagonal line of something like this, and we start here and not there because we said the initial acceleration was somewhere above 0. So here we have time. So let me just label the axis because it might be easier. So we have time and we have velocity. And here is practically at this given time, this given time, which is somewhere over here, its speed is this much. But at another given time, its speed is higher, it's somewhere here. And that speed keeps increasing. And what do you call increasing speed over time? Well, acceleration, obviously. And now we get to the area beneath the graph, right? So we take this. And aha, you might see this is not a square anymore. You have to apply the rules of a trapezium for this, and which is a bit more complicated. But anyways, the area beneath this graph will be showing the basic and if you don't know, oh yeah, if you don't know how to solve the area of a trapezium, what you could do, and I didn't know how to do it either. So what I did was just draw a line over here, just for myself, and we find the area of the triangle and add the area to the rectangle. So you find how much this is and how much this is. So so we have here the area of the triangle, which is height times base divided by 2, but it's the same, velocity times time, right? And so the area beneath this graph also shows distance, and the area beneath any velocity time graph shows distance. So now we get to another type of graph, which is distance graphs. So it's distance over time. So you have distance and time. It's just called distance v because that's how they show distance in physics, and we have time over here, right? And let's say you want to show average increase in speed. So the speed is increasing over no, not average increase, average speed. So the constant speed, the speed is constant. So from last graph you might think, oh, just draw a line over here, but no, that's wrong, because this is distance now. So if you want to draw constant speed, what do you have to do? Well, in a constant speed, the distance is increasing over time. So in that, you have to draw a straight line like this, because this is not acceleration. Do not confuse this with acceleration, because this is distance over here, and if there's uniform or constant speed or velocity, there'll be increase in distance over time. So that's why you draw a line like this one. And I hope you guys are understanding this. It was quite confusing for me at the beginning. But so you have distance and time. So at any given time, an increase in time always symbolizes an increase in distance, which is an average speed, because you're traveling more distance as the time progresses. Now we get to the area beneath the graph, which is a basic triangle, which should be easier. So this is distance times time, right? And distance times time is divided by 2, of course, and that is the distance traveled. So practically the area over here is the speed, distance times time. No, what am I doing? Distance times time is not it's not speed. Anyways, so distance, the distance traveled, distance multiplied by speed. And what is that? Well, there isn't really anything anything that shows what distance times speed is. So you won't have to do areas beneath the graph for this certain graph. Now we get to another graph, which is again the same axis, but let's say you want to show constant acceleration. Now what do you do if you want to show constant acceleration? And this I have no idea if you're going to be getting this in grade 9, but it's still a good idea to study it, you know, because if you want to show acceleration, how do you do that? What if you want to show constant acceleration? So practically increase in speed over time, but this is distance. So then what you do is you draw one of these you draw one of these graphs, because it's increasing exponentially. So as you can see, it's increasing a lot over time, and this will keep going like that. So it's it's practically how should I explain this? It is it is getting steeper, and yeah, exactly, it's getting steeper, because when it gets steeper, it means it's traveling a lot of distance in a very little time. So let's say you just have a straight line. What does that mean? That means it's not traveling at any time, it's just going distance. So practically it has stopped time and it's going really fast, but that point never increases, because this graph never gets parallel with a straight line like this one. It never gets parallel. It'll get closer and closer to being parallel with this line, but it will never get to this line, because that means it's an increase in speed. So it keeps increasing its speed. Uh, it keeps increasing its speed over time, and once it does that, it means it's traveling more and more distance, and it's covering the distance at a really high rate. So practically, if it's somewhere over here, it will be a very, very straight line. It will be something like this, right? It's almost straight, but not really. So it'll keep getting closer to a straight line, but it'll never get there, because obviously you can't stop time. And that is the distance over time, and you won't be able to. You're definitely not going to be studying the area below this graph, because, well, you can't. It's too complicated. And sorry about this, is equal to, yeah, NA, you could say. So that's it for the graphs.